We're actually going to talk about circuits, and circuits basically are a complete path in which the charges can actually flow. So what you have right here, we start with the battery source right here, and it travels around, and basically you want to end up back at the battery. Okay, there are four types. You have an open, a closed, a series, and parallel. Okay, so these are just in drawing the circuits on two-dimensional on paper. What we have right here, this first one over to the side, is a battery source or your source of power. This demonstrates the switch. These images, especially this one that I'm swirling my mouse around, my pointer, is actually at the light bulb. The straight lines represent the wire, and then the arrow represents your current flow. So now let's talk about between an open and closed circuit. A closed circuit is one of those in which there is no switch and electrons can flow automatically through that one. It's basically if I take a lamp and I plug it in immediately, it cuts on without me flipping a switch. Try to think of some other examples that could be a closed circuit. We'll have that discussion in class. An open circuit is one in which you plug it in, but then you've got to cut it on in order for it to work. You're actually completing the circuit by flipping a switch and making that connection to allow those electrons to flow. That is an open circuit. Okay, an example of that would be a lamp. Okay, now today we're going to experiment between series and parallel. A series circuit is basically one, like the diagram down here. There is one path. There's one continuous wire where lamps are included in it, and one path to get back to the light, to the actual battery. And now, cool fact to note: if one light bulb goes out in a series circuit, then all of them go out. Okay. So like, have you ever been in your house and all of a sudden the power goes and then everything goes out? But yet some lights are on. Well, the ones that went off are ones that were developed or set up in series. Okay? A parallel is multiple paths. So if we look at this diagram down here, we can see multiple paths attached, so where electricity can actually flow to that light bulb. Okay, I can find different pathways. So if one light bulb goes out, let's say this first one goes out, then the other two will still get enough electricity in order to flow, or in order to allow electrons to flow through that path. Okay, now here's some more information. In a series, the more bulbs on a circuit means there's going to be more resistance, and the voltage will drop, causing the bulbs to dim. So basically, the more bulbs you load up in a series circuit, the brightness of the bulbs are going to get less. It's actually they're going to become dimmer. But in a parallel circuit, by setting it up in different branches, the voltage is basically going to be the same throughout each of the paths. Therefore, you're not going to see any difference in the dimming of the bulbs. So therefore, parallel is much better. In fact, your home and most items wired at the school are set up in parallel so that if the power or something fails, it won't affect all in a home or in a business. Okay? Are there any questions? That is it for today. Thank you.